Okay, so I'm going to show you both methods. We've got our given vectors. We're going to put these in a little box here. Remember, vectors can be moved anywhere in space as long as you keep the same magnitude, so basically the same length as the best of your abilities, and the same direction, so the arrow stays in the same location. We're going to start actually with the second method. So on the previous slide, we said there was two methods that you could use to draw the resultant vector. The resultant is the sum of the two. So with this, we're going to start with method number 2, which is to have them both starting from the same location. So we'll take vector v, slide it down, there's v, and then at the same starting point, we're going to draw vector w. So we're going to take vector w and slide it down, there's w. We did the best that we could to recreate that exact length. And then the resultant vector is just directly in the middle and somewhere about the same size. And if you can tell, that was really hard to estimate. I don't know if that's even accurate. So with this method will make sense when we come back to doing some applications where maybe we have two forces acting on a single object. So this would be the object, and we would have two separate forces pulling in different directions. For just graphing and finding the resultant vector, method 1 is much easier. It's much more efficient. So we're going to start with the first vector, vector v. I'm just going to recreate. Then, instead of starting in the same location, wherever the first vector stops is where the second vector is going to start. And we're going to just do vector w, so there's v, w. The resultant then connects the first point you drew to the last point you drew. And if you notice, these are very similar, but that was a whole lot easier. There was no guessing on approximately how long or what angle do we draw this at. So this method, first method, would be the way that I would do it. U plus W, whoops, let's keep this here. We're going to start with vector U. I'll show you both ways. This is method 2. Like I said, I would not do it this way, and I'm going to show you why, just because it is harder. There's U. And then we're going to draw vector W. Ooh, that's an estimate. Somewhere in there would be the resultant. Method 1, like I said, is what I would highly recommend you use. U, and then where U stops, W is going to start, and that is my actual resultant. Make sure that when you're drawing resultants that you put the arrow in the right location, because otherwise you don't have a vector, you just have a line.